Okay, ladies and gentlemen, so for today, right? This is our lesson today. We're gonna learn about the structure of the eye. So, my webcam is here and my video is mirrored. Okay, so ladies and gentlemen, first of all, what is the eye used for? Bear in mind I'm teaching Form 3 students, so expect a lot of smart comments. What is the eyeball used for? Alright, okay, fair enough. That's a good answer. So, the eyeball is used for seeing, ladies and gentlemen. So, how does it do that? What's the basic principle behind that? That's what I want to ask you all. What's the basic principle that helps the eyeball see? Alright, fair enough. The basic principle is rod cones and light exposure. Rod cones, cylindrical cones, we're not covering that today, ladies and gentlemen. That is not part of our lesson. Our lesson here today is to help y'all understand what all the different parts of the eye are here for. That will be the next session, ladies and gentlemen. But that is a wonderful recap. So, I will go through this one by one, and then we're gonna do some revision where I will blank out these bits, because yes, ladies and gentlemen, memorization is the name of the game. I was a kid once, and I guess you're a kid. You're a kid right now. You learn, kids. You learn. The world only values memorization. At least the Malaysian learning educational syllabus only values memorization. So that's what I'm gonna ask you to do today, ladies and gentlemen. First of all, I hope you can see my cursor. Yes, you can. Okay, fantastic. So, this is the cornea. This is a clear area, the sclera, which helps to bend light into the retina. So, any of you wear contact lenses? Yes? No? Okay, so do your contact lenses ever feel absolutely horrible? Alright, why is that? Okay, it's because when they hit your cornea, your lens is dry, especially if you don't put on enough of that lens cleaning lubricant juice, whatever. So, it hurts. This cornea is also what supports the front end of the eye. So, what's in front of the cornea, ladies and gentlemen? Which layer protects the cornea? I'm playing Dora the Explorer here, ladies and gentlemen. Yes, the answer is correct. This thin layer, the conjunctiva. Okay. The thin layer over the front surface of the eye and the eyelids. Ladies and gentlemen, this front layer is kind of like the screen protector on your phone, and then this back part is the glass. So inside is like the camera bits in your phone. So this conjunctiva is the screen protector. This is what hits your, this is what hits your contact lens, and this is what hurts when you get something in your eye. Okay, so what's the next what's the next section back? Alright, the next section back is the pupil. So, the pupil is the hole in the middle of the iris which the light enters the eye. So, can anyone tell me the difference between the iris and the pupil? Don't worry, you just have to give an answer right where you're sitting, right there. Because I am playing Dora the Explorer. This is the iris. So, how do you differentiate the pupil and the iris? The pupil is the black bit. Hold up, let me pull up. Let me pull up this image real quick. Ladies and gentlemen, here you can see this is the iris, this is the pupil. The pupil does not actually exist. The pupil is a hole. The pupil is a space. It does not actually exist physically. The pupil is just a hole. Do you understand what I'm saying here? The iris is the part that actually expands and contracts. The pupil is just the middle part. Okay, everyone got that? Good kids. Okay, so the next section is the iris. This is a colored sheet of muscle which controls the amount of light which enters the eye by changing the size of the pupil. So, alright, pupil. Pupil. Proper pronunciation, ladies and gentlemen. Don't be like me. Say pupil. Don't say pew-pew. Say pupil. Don't be like me. Okay, colored sheet of muscle. Why is it colored? Hold up. So, this is white people problems. I'm sorry, I'm not being racist. It's just that white people normally have a higher percentage occurrence of blue eyes. We Asians, we normally have brown or black eyes, and that's because... Anybody? Anyone? Because higher concentration of melanin. Now, why is that? I had to Google it. Yeah, I had to Google it. I'm just a kid. But I'm your teacher. So you better listen to me, or else. Okay, so this is because we are exposed to a lot more sun than Westerners, who live in 4-season countries. Hence the occurrence of, well, blue irises. Whether that's hot or not, that's up for you to decide. So, eyelid. Okay, never mind. We're not going there yet. We're slowly working our way into the eye. The eyelid is very obvious, so I'm skipping it for now. It's just a lid. It's just a cover. If this is the screen protector and this is the screen, this is the armor casing on your phone, okay? The eyelid is just there as an armor casing. It doesn't actually have anything to do with your eyes. Okay, so next layer in, you see the lens. So this is a clear disc which focuses the light into the retina. It gives fine focus. Why is this, ladies and gentlemen? How does it give fine focus? Alright, so it gives fine focus by stretching up and down. So you see these ciliary muscles, right? They change the shape of the lens when they contract. So, this interacts with the lens by basically stretching it out like this. So you see like how my arms, right? Where the closer they get, I have thicker arms. And then when you stretch them out, I get thinner arms. Same concept with the lens. The difference in the lens, the amount that it stretches is really quite small. It's about much less than a centimeter, but it's more than enough to give it a distortion like this. So if you can see my hands right here, when the lens is stretched, it gets thinner, and when it's not stretched, it gets thicker. So that's the rough motion of how the lens works. So we'll cover how it works in the next lesson, as well as why some people have farsightedness or nearsightedness, as well as the reason why I need these glasses. We'll cover that in the next lesson, because we're going on to the suspensory ligaments. These hold the lens in place and connect it to the ciliary muscles. So these are just suspension, connection, tendon, ligament. They all do roughly the same job. This is an oversimplification, don't at me, but yes, that's what they do. So there's a choroid, the dark pigmented layer which absorbs light and stops it being reflected back into the eye. So, have you ever wondered, right? Look at the back of your phone. Look at the back of your phone right now. I have a black phone, right? I have a black phone. Look at it right here. Camera lenses are all black. And right here, I have a spare phone. Look. The color is green. The color is green, but the camera lenses are black. Have you ever wondered why that is? Well, that is because if you were to make the inside of these lenses white, right? let's say you make these inside of these lenses white or green like the color of this phone, right? All the light that goes into here would reflect right back onto the glass lens that covers the camera. And it would ruin the photo quality. Any one of you who wears glasses, have you ever gone to one of these fancy restaurants where there's a light on top of your head like this, and then it shines right down, and you're looking at your food, and then all of a sudden when the light hits your glasses, right, when you lean forward, you want to eat your food, the light hits your glasses and you go blind because everything is white. Yeah, this and the choroid, they all have the same function. This dark pigmented layer which absorbs light and stops it being reflected back into the eye. Stops it making very weird artifacts. Okay, so this, okay, a difference. You see these phone cameras, right? These phone cameras, they have air in between the casing and the camera. So we'll skip the lens for a while. There's a camera lens in this. I don't want to talk about that. We'll just talk about the camera and the outer casing. The outer casing right here on this particular phone is plastic. I don't know if you can hear that tapping. That is plastic. This is not the lens. This is just a camera cover. This is plastic to stop it from being like smashing up and all that. So there's air in between the equivalent of the conjunctiva / cornea and the retina. We'll get to that later. But inside your eyeball, there's juice. There's vitreous humor. It's juice. It's jelly-like fluid which helps to keep the shape of the eyeball and bends light onto the retina. So, I got a question for y'all. Why juice? Why liquid? Why can't this just be air? Anyone? Anyone? Okay, so the simple answer, nature abhors a vacuum. Nature hates internal things being vacuum or empty. If this were air, your eyeball would be distorting all over the place and you wouldn't be able to get constant vision. Why? Because your eyeball right now is squished. It's squished by the other tissue surrounding the rest of the, let me move my camera out of the way. It's squished by the, hold on, there we go. It's squished by the bits and all that around. We'll get to anatomy in a future lesson, but let's just say that you have muscles all around here, you have flesh, you have bones. All of these are putting pressure on your eyeball. If your eyeball does not have internal pressure to keep it like a balloon, you know, the air inside the balloon, you gotta blow into it. But instead of air, there's water inside the balloon that is your eyeball. All of this is to make sure your eyeball has a constant shape so that your lens is not working over time, and to maintain a constant focal distance. But that's the next lesson, ladies and gentlemen. The optical properties of water are also a little bit different. Have you ever heard of like how it's difficult to hit the target while you're spearfishing? You probably learned this. Yeah, this diffraction, light diffraction. You've probably learned this in Form 2. That's the next lesson. Lesson. Hiss your S's and your sh's. Okay? So, the final layer is the retina. It's not the final one, sorry. The layer of light sensitive cells which send impulses to the optic nerve. So, the optic nerve is just a fiber optic cable. It takes the It takes the input to your head, and your head processes it and it sends the input out. So, the retina is a layer of light-sensitive cells which send impulses to the optic nerve. Part of the retina is the fovea, a small area of the retina which contains only cones. So, let me nerd out here a little bit. Have you ever heard of Samsung's dual pixel system, where there is a higher concentration of pixels at a particular space, and they kind of layer the pixels on top of another? That is a kind of rough description, not totally accurate, but a rough description of what's going on with these fovea. Only cones, only color, not so much black and white, and maximum sensitivity. So, blind spot on the other hand. The optic nerve leaves the retina right here. It leaves the eyeball. There is no retina. Why? Because all of this is just nerve tissue. Nerve tissue is not a good mounting platform for cone cells and cylinder cells. So, right here, all these cone cells and cylinder cells, they are supported by the sclera. It has blood vessels with the retina, which supply the retina with food and oxygen. This is the white part of the eye, ladies and gentlemen. This is a white part of the eye that goes all around the outside. This is the bit that helps you see where the people are looking at. If you're Chinese like me, nobody can see your sclera. Yeah. If you're Chinese like me, people only see like a little bit of your iris and a little bit of your pupil, and that's it. Nobody will see your sclera if you're Chinese. And this also provides the backing for the retina. This is important because this is the balloon surface. This is the balloon surface that like holds everything together. You have the internal pressure of the vitreous humor, and you have the external shape which is maintained by the sclera. So yeah, ladies and gentlemen, that's today's lesson. It's all the basic bits of the eyeball. Now go home and memorize.